Right, so Zeta Alpha Trends in AI live from the expo floor in NeurIPS 2022. We have as guests the team behind MineDojo. Welcome.
Thanks for having us. Yeah.
And congratulations, you have received the Outstanding Paper Award for Datasets and Benchmarks, I believe. Congratulations.
Thank you
Great
so much.
work.
Yeah.
So we really like the paper.
Yeah.
It's kind of, you guys did a lot of work, so we want to dive into it, but maybe let's first introduce yourselves.
Oh yeah, absolutely. So my name is Jim, and I'm currently a research scientist at NVIDIA, and I work on like embodied agents, open-ended learning, large-scale models, foundation models, and robotics. So previously I graduated from Stanford, got a PhD degree last year.
And do you play Minecraft professionally, or?
I want to. And a reason we started MineDojo was because I don't think any of us is good at playing Minecraft, and we want to create an AI that can play Minecraft better than we do. So yeah, that's a dream.
Yeah, hello everyone. So my name is Guanzhi, and I'm a second-year Caltech PhD student. My advisor is Professor Yunfan Jiang. Previously I was an intern at NVIDIA, and also frequently collaborated with like Jim and also some other professors like Professor Zhu. Yeah. So I'm also quite interested in large-scale models for decision-making for robotics for reinforcement.
Yeah.
Yeah, so I'm Yunfan, and I'm not as good as them. I'm still a master's student, and I'm applying PhD
good.
this year.
Really good. Yeah,
So you did all the work, actually.
Yeah, some engineering things, stuff like that.
So I think it'd be interesting if you guys can, for everyone who's not familiar with it, you can give a short a pitch of like what work you did with MineDojo.
Yes. So I think for like large foundation models these days, like GP3, most people are familiar with GP3. It's kind of this
3.5, 4, maybe.
Yeah, 4 is coming. Hopefully, we'll see that sometime soon. So for those who don't know about it, like GP3 is this large model where you can just give it a text instruction, like a prompt, and you can specify what you want, and then GP3 can do that for you. Be it machine translation or like summarization or reasoning, just explain it in text, and then GP3 will do that task for you. But the thing is, GP3 is blind. Like it does not take actions. It cannot proactively make decisions and react to a changing world. So it does not have like hands and legs to like enact changes in a world. And in MineDojo, we want to build this embodied version of GP3, where you have an agent that receives like an arbitrary English sentence as an instruction, and it can do whatever you want. But it performs the task in an embodied manner inside an open-ended world. And then we landed on Minecraft because Minecraft is, I think, the top-selling video games of all time. And the reason is Minecraft is super open-ended. Essentially anything that you can imagine, you can build it in Minecraft. You can build castles, you can go to like
the original metaverse, right?
The original, yeah, exactly. I always say it's kind of like a lo-fi metaverse, right?
A bit square.
It's voxels, it's voxels, quite lo-fi, but it has like all the properties of metaverse. Like anything you can imagine, open-ended, you can do it. You can do it in this game. So I think Minecraft is perfect for kind of this generally capable agent to emerge. So that's only one part of the story. Like you have this game that's open-ended, but how to train this agent? Like if you just let the agent run loose in the game and do some random exploration, it will never find interesting things to do. It's just impossible to do like exploring all of these complicated terrains and tools and crafting. So the way we do it is we scrape huge amount of data from the internet. So we call that internet scale knowledge base. And we have 3 parts like YouTube, Wiki, and Reddit.
Yeah, and text and video, right?
Text and video, and that's because human players they generate huge amount of data online because everyone loves Minecraft. Yeah. They want to show like what they have done in Minecraft, and people make tutorials. People explain literally every concept of the game mechanics in wiki pages. There were like 7,000 wiki pages detailing every single aspect of the game. And then you also have Reddit, people kind of discussing like vigorously on those forums about strategies, about interesting things to do. And this is a huge treasure trove of knowledge that we want to take advantage, and we want to give that to the agent, so it doesn't start from zero. It
And
starts
you guys
from,
open source all of that, right? You just
yes,
kind
we
of
open source,
releasing it to the community.
we open source the simulator, so you can use an AI or use like really any algorithm to control the agent inside the game. And also we open source the data set, so anyone can kind of use the data set and develop novel algorithms towards generally capable agents.
Yeah. And what did you guys do in the project?
So I mainly work on the data collection and cleaning. So basically,
Yeah, so the scraping of all the
Scraping,
data. And
It is a very complicated pipeline.
very
that we've
complicated
done,
pipeline because it's not that easy to collect all of the YouTube videos about Minecraft. So basically, we need to do a lot of searching, like using some keywords, find some YouTubers. Some YouTubers have a lot of like videos about playing different games, and we need some kind of
filter
annotation
down.
from the
Yeah.
YouTube trying to find what videos are Minecraft.
Yeah.
And even for the Minecraft videos, some of the videos don't really have video transcripts or video
Right.
subtitles.
So what's the total amount of videos that you guys collected?
So we have collected around 700k YouTube videos
Wow.
about Minecraft.
Wow.
Yeah.
And
Didn't
that's
even
not
know that
all of the videos
I didn't
on
even
YouTube.
know that existed.
And we can keep scraping because like every day there's gonna be new videos, tens of thousands of new videos uploaded about Minecraft.
Also, you're augmenting the data as you
Later,
you
if
keep-
we want to
okay,
keep augmenting, we can keep
Yeah.
doing it. But at the time of the paper release, it was like 700k.
Right. And how about you?
So I'm responsible for designing this task suite. So we have like 3,000 tasks.
Yeah, and they're defined in natural language, right?
Yeah.
To a large extent, or all of them?
It's not like super hard. We have some, prototypes, and we have a lot of different methods to scale it up.
Yeah.
So like we can do a Cartesian product on like items and different difficulty levels to scale it up. And we also have designed some creative tasks like building house or stuff. And we use actually GPT-3 to then write some new creative prompts, which we found very interesting. So that's how we designed this task suite. And we have a lot of for now.
Yeah, so it's purely synthetic data in that sense.
Yeah,
It's
and we will
more like hand curated, like curated tasks
Right,
in
right.
the bench.
Yeah. Very cool.
So you've kind of sketched a bit how in the pre-training you both leverage textual data and video data.
Yeah.
Can you go a little bit more in depth in like how you fuse those two
Absolutely.
modalities?
Absolutely. So in the paper, in addition to kind of the simulation and also the data set, we also introduce kind of a recipe to train a foundation model using these data. So in particular, when humans are playing this game, let's say on YouTube, they're streaming, you have the video, and they love to narrate what they're doing. Like they will say, okay, now I'm gonna go on this quest, I will dig the deepest hole I've ever done. Like they will talk about it. And then you have time-aligned transcripts with the video, and the transcript is essentially describing the activity present in the video.
Yeah.
So that creates like a very good kind of supervision signal for us.
And you use that to train some kind of clip model, right?
Exactly. So we use that to train like contrastive model, where we kind of learn the association between the video and the text. And then once you have that model, we can repurpose it into a reward model. So reward means we encourage the agent when it is doing the right thing, and discourage it when it isn't on the right track. And the way that is done is when the agent is interacting with the environment, with the game, it will generate a little video as it explores.
Right.
And then we have a task that we wanted to do, like let's say obtain wool from a sheep. You need to have a shear, and then you need to shear the sheep to obtain the wool. So we have that in the text. And if the agent is approaching a sheep, then this model will reward it. Otherwise, it will penalize it. Because as you approach the sheep, it becomes more and more associated, like the video activity and the text, sharing a sheep.
Yeah.
So that's how we kind of give it guidance through this contrastive training.
By encoding kind of the goal.
By encoding these kind of goals and also like...
So in a way, the reward is like the distance or like the similarity between the encoding of the video and the
encoding
of
of the prompt.
Of the prompt,
of the text, and the instruction text. And then we use that as a signal. And the good thing is it is a dense signal. It is continuous, right? It's not like, oh, you succeed, I tell you you succeeded, otherwise I just stay silent.
Right.
It's going to give you, okay, you are now like 20% there. You are now 80% there. It will give you a continuous score. And by following the score, using like state-of-the-art like reinforcement algorithms, then the agent can solve many of these tasks. without like human kind of hand holding, without teaching it explicitly.
Yeah, and so you guys have released this data set and in the benchmarking environment, but you've also built some baselines, right?
Yes, so we also released what we call this the MineClip model, because it's based on OpenAI Clip, it's for Minecraft. So we open source a MineClip model. We also open source the agent implementation. So yeah, anyone can kind of git clone our GitHub and then play with it.
Right.
So. So I've seen a couple of other works in this year's conference, NeurIPS, that kind of like are in this space of sort of leveraging language model techniques in the sort of like in the reinforcement learning world as some kind of players to have more efficient exploration.
Exactly.
And I think that's a super interesting line of work. Now this is all still in a setting where the agent acts in a simulated environment, right? We're not talking about robotics with robots that act in a physical world. What can you say about implementing this kind of efficiency techniques to build or kind of to train robots that end up performing tasks in the real world? Like how far are we to achieving this goal?
I see. I think that's a great question, and indeed we've thought a lot about kind of how to transfer some of these ideas to robotics. So I think one way is our methodology of training this reward model is transferable to robotics. So let's say you can scrape, again, like in the same pipeline, you can scrape a lot of YouTube videos of humans doing like household tasks, and then there are like text descriptions of it. And if it's like a cooking video, typically when it's a tutorial, people also talk about what they're doing, right, as they're cooking. And then you can train this contrastive model and use that as like a real-world reward model to a robot agent, so the robot can try to imitate what a human is doing. Like if the human is cooking, then if the robot also gets the right items, then it's 20% there. And if it puts in a frying pan, that's 40% there, and you can nudge it towards the behavior that you want. So I think this kind of algorithmic insight will be transferred.
And can you imagine that to take that further, you could use like completely automatic captioning of video and bootstrap it from there?
I think that's a good idea. Maybe we should do that next. Yeah. So there are like video kind of captioning models, but those models are also like pretty hard to train. It takes a lot of compute. I'm not sure if there's like good open source video captioning models. Maybe there are. So
if not today, then maybe
maybe
next
we
week.
We can make it. Yeah. AI is like building so fast, and anyone seeing this video, please build this so we can use your model for our next project. Yeah.
So there's also been this quite popular work called video PreTraining on Minecraft, which I think is similar in some ways, but also different. Can you talk a little bit about like what are the similarities and what are the differences with your work in that?
I'm very glad you bring this up. So actually, this is like pure coincidence that NVIDIA and OpenAI are like both working on Minecraft in parallel. We don't know about each other, and then we release almost on the same day.
It was in the same week, right?
It was in the exact same week. Like our archive went first, and then OpenAI's blog post, and then like MineDojo open source, all in the same week.
We did find similar paper search, and then we discovered it.
Right. Yeah. But I'm very glad because it feels like the community has been kind of converging on Minecraft being a very good test bed for like generally capable agents. So regarding the video PreTraining paper, I think because we developed both projects completely independently, we approached the problem completely differently. So that is pretty fascinating. So from our end, we trained this reward model, right? And then the agent is trained by reinforcement learning. And from their end, what video PreTraining did is they first collected like human contractor data, and then trained an inverse dynamics model. So what that means is kind of given the previous game frame and the next game frame, infer the action that the human players took that transition from frame to the next frame. And then once you have this model, you can use that as a pseudo-labeling technique to label in the wild YouTube videos. And by the way, they also use a lot of YouTube videos. And then you essentially have like those YouTube videos with the inferred actions that would have taken by those YouTubers when they were playing the game, because you don't have direct access to the actions, the keyboard and mouse actions of those YouTubers, right? But now you kind of have like a noisy version of that, and then you simply train an imitation learning agent to predict those actions. So I think the ingenuity of VPT is they go to the keyboard and mouse level. So the actions in the game is the same as the actions that you see on YouTube, and that's why this labeling works. And then you can train like very long horizon policies. Yeah, and I think the strength of MineDojo is we made language the first-class citizen. So language is a key part in our transcript, also on the conditioning side. And VPT did not deal with language, but I think like it's quite straightforward to combine these two approaches. And I do believe in the future works we should combine these two approaches. They are like super complementary, and I think it's going to be very promising. Yeah. Yeah, for the community. Yeah.
All right, so check it out, MineDojo, outstanding paper award at NeurIPS 2022, and a lot of potential for future work. How's your NeurIPS so far?
Really good, yeah. And it's great meeting you guys, meeting everyone around the world. Yeah, it's been amazing.
So thanks for joining us.
Thanks.
Yeah, thank you so much. Yeah,
enjoy the rest of NeurIPS.
Yeah, thanks a lot.